save the figures associated with our plotting options. So I will start with the basics of the graphics. So this is the contents that I will be covering in this session. We will start with the 2D plotting, then various graphic annotations that are used in the 2D plotting, then subplots and alternate axes, how to define the alternate or multiple axes in case of plots, or how to define many plots within a single window. Then we will switch on to the 3D plotting, advanced plotting techniques, specialized plotting routines, how to extract the data using from the available patches or images. The images can also be used to extract the data from them. That technique we will discuss over here. Saving and exporting the figures to the different softwares. We can save our files or export our file in terms of JPG or .TIFF. How to do that we will discuss. And finally, we'll discuss introduction to handle graphics. Handle graphics is generally how to change the properties associated with the Matlab figures. And later on, we will discuss 2-3 problems based on solution of partial differential equations as well as ordinary differential equations. So when we talk about 2D plotting, the requirement for 2D plot is to specify the X or Y data. Y is a dependent variable and X is the independent variable. So we need to define that in the Matlab before the plotting. This is the prerequisite of the plotting command. The common syntax of the plotting command for a single plot. Single plot means Y versus X. It is plot X data. So we need to define X variable, Y data, then the array containing the Y data. And then we can change the properties associated with the lines by using the different line styles, specific color or marker symbols. These properties can be changed by using this syntax. If you want to plot multiple lines, then we need to define the syntax like this: plot x1, y1, and this is CLM1, means the properties associated with the first line, marker style, line style, or specific color. Comma separated by x2 and y2, this is the second set that we want to plot. On the same plot, we can define it like this. And again, the properties associated with the second plot. So moving on to the one of the example, let us say that we want to plot the sine curves. So how to use that? The common commands have been defined over here. So you can see we can directly type these commands into the command window and the system will execute the command, or we can save them in the script file, that is .m file, and we can call all these functions. So I have already saved all these files in a script file, so I will be calling the first command. So first I will define the X variable. If you found any difficulty or if you want to try these problems simultaneously, then you can open your Matlab software and do as I am processing all these problems over here. Okay, so first we will define the X variable. Now this command has been used to define the X variable. X will be varying from 0, then with a spacing of 0.1, it will move on to 2 pi. So 2 pi is the maximum value, 0 is the minimum value, and 0.1 is the increment between the successive values of the X. So when I will execute this, what I have to do, either I can copy it and paste in the command window, it will run. Okay, so you can see the execution have created 63 columns, single row, 63 columns. Okay, so by executing this command, what we have obtained, we have obtained the values from 1 to 63. We have defined an array of X. Now you can see the semicolon have been defined over here. It has been used to suppress the output of that in your script file. Okay, so now we have defined the X value and the same value that over here. Okay. Let me one more. First, I will clear the workspace of previous variables. Clear all. It will clear the workspace. So all the previously defined variables have been vanished from here, this workspace. So again, I will define the x. So this is how the x has been defined, and you can see the variable have been created in the workspace x. When you double click it, you will get the same value as an array. Now, y is equal to sine x. I will execute this command. Again, one more array has been created, y, which is y is equal to sine x. And now I will use the command to plot this figure, plot xy. So this figure will be created. We can change the properties of the axis, y-axis, x-axis. We can add the legends. We can change the font types, font size, colors. We can also introduce the markers on this sign graph that we will see how we can do that. So let's say you want to enable the grids on it. अगर आपको ये grids इसके ऊपर show करनी है तो एक command होती है grid on. So once you execute it, either copy or paste it, or you can simply evaluate selection in the command window. So it will directly go over there. Okay. So again, let me create the image. This figure we have created, you can see. And now when I enable grid on, the grid will be created. You can also change the spacing between the grids and so on. And also you can insert the minor grids, that is the minor grids between these grids, by using the change properties, or by also defining the certain handlers in the command window. So next, let us go to the next one. Now we want to add an overlay plot. एक और plot हमें इसमें add करना है. Okay, and that plot is a x is a function of exponential of minus of x, and that has to be indicated in the red color and by using the asterisk. Instead of the lines, we want to use the asterisk, star values we want to use to depict the variation. So for that, one command is known as hold on. Hold on means that that you are enabling the figure to add another plot in it. So this is our plot. You can see we can simply execute hold on. Now plot x, and instead of defining the y like this, I can also define it in terms of function exponential of minus x. Okay, and then this is the property associated with this plot. R correspond to the red color. Okay, and O is the marker. Okay, so let's say instead of O, I will use star marker we are using. So I will execute this command, and you can see what is the effect. This overlay plot has been added to the figure. Okay, now let's say I want to change the axis of the plot, or I want to define the x limit and the y limit. So for that, command is axis bracket. First we will define the x limits 0 to 2 pi, and let's say I want to increase the limit of the y-axis from minus 1.5 to 1.5. Right now it is completely fitted over here. So we will run this command. Evaluate the selection, and you can see now the y is from on the vertical axis minus 1.5 to 1.5. Okay. Another feature to complete this image is we want to add the x label and y label. Means x axis का name करना है हमें, y axis का भी name करना है, और इस figure को एक title भी देना है. So for that, the syntax is y label. This command we use label. You can see y label, and inside the bracket we have used the string. String means it will get repeated. Whatever is written in the string, the same will be appear on the axis. But first we have used the backslash over here. Backslash means we want to call some function, and the function is BF, means bold face. Whatever will be the written in the string, that will be coming in the bold. So let me execute it again, and over here you will. So slash B F be appearing, but it will be made this one bold. Okay. On x-axis we want to add, so x label boldface and x that will be written in the, and you will get x over here. If you want to add the title of the figure, then the syntax is title bracket string, then backslash font size. We want to increase or decrease the font size, then we need to define the specific value. So within this parenthesis we 14. So 14 font size. Again backslash BF means it will appear in the bold. Then 2D floats. So this title will appear over here. Figure. Okay. So if you want to save it, then simply file, save as, give the name, and see that the extension is dot. So that can be opened up later on. Any doubt? किसी को doubt है इसमें? Okay, then moving on to other features. Let's say you want to create a plot. Again, in the same plot, if you want to define the legends, I have 2D plot field. First, I will. This is another one. So I simply execute the command again. So on that plot, what operations have been done over here? You can see the y label has been defined. Is it different problem or the same one? Okay, it is the same one. So what you want to add? You want to add the legends to it. Okay. So we can have the different manners we can define using the command window, as well as we can define the legends directly by using the properties that are available in this figure. So we can go to the tools, and in the tools or in the edit figure properties. So all properties will be appearing over here, which are associated with the axes, with the lines, with the grids, colors. Everything will appear in the property inspector toolbox. So from here you can define the legends. Just click on the mid of this one and to locate the legends. This line I will select in. Okay, no issue. You can also define the legends by simply writing over here legends. The first one is your sine wave. Okay, and second one is within the strings we need to write it is decaying exponential. So we will execute this. Okay, as it will not take only legend. So now if we see the figure, the same figure, the legends will appear in it. Okay. And if you want to change their font size, you can also define it by editing the figure properties. one toolbox will appear. Some error is going on. Toolbox. This one is okay. So if you want to change, the string is over here in labels, sine wave and decaying potential. If you want to change their font size, you can change it like this, 14, or you can also do the same by using the handlers. You can also define like Cambria, we want to change the format. So you can use the property inspector to change all the properties associated with the figures as well. So now moving on to, let's say if you want to define certain, or you want to write certain text over here, so you can use the command gtext or simply the text. So we will see how to use the gtext. Let's say like this, you need to type gtext and execute it. So it will ask you where to enter the text, this crossbar. So simply click over here and the arrow symbol will appear on it. If you want to add the text, so you can add insert any text with arrow like this. Okay, so if you want to add the text, let's say this is sine wave. Okay, so the text has been added. You can reposition it like this. And also using the property inspector, you can change the properties, that is the font size and everything of this line. Okay, is it clear to you? किसी को डाउट है इसमें? Now these are some of the latex special characters that how to change the properties associated with these figures. You can see slash font name. In the font name parenthesis, like over here we have done. Let me again create one more plot and we can execute it. Okay. So this plot, hold off. Now I will create another plot. So this is for cosine wave, this is for sine wave. Okay, the markers have been defined. You can see these are the function of the time. So over here I have defined an array for the time starting from 0 to 0.5 seconds with a spacing of 0.05. Then I have defined a variable x as 10 pi. Okay, this one is the problem. So this is the sine function. It is 10 pi t, cos 10 pi t. This one is for sine 10 pi t. I want to write the title like this. Font size is 14, and the font type is Courier, New World. Normalized signals I want to write. I want to give these circular markers over here and over here another type of the marker. So how to do that? So I have defined the first variable, that is the x-axis, as time. So this array I have created. You can directly see the output of it. 51 column array have been created. Then x is a function, okay, and that is 10 pi t. So x we have defined as 10 pi into t. It will give the value of theta. So again 51 values will be getting. Then for x we create y1 sine theta, y2 is for cos theta, and after that we have created the plot. So this is the multi-plot. So this t will respond to the x coordinate, x1 y1, g is the color, green color, and this is the star is the marker that has been used in the first float. In the second one, again t is the x variable, x type of the variable, y2 is the second variable we have defined. It is of red color and it will come with the dashed line, and O will be the, or 0 will be the marker in this case. So I will execute it and you will get this image. Next, we need to define the limit of x-axis. You can define the x-axis, a-axis, or you can use x limit. X limit is from 0 to 0.5 that we have already set. Okay. So it is already fitted. Then y is from minus 1.5 to 1.5. So I will execute both these commands and you can see the difference. Minus 1.5 to 1.5. On x label, we need to write this one, time microseconds. So x label string backslash font name. Font name is your Courier new. And if you want to make them bold, then again slash boldface. Okay. And then you need to write the x label, that is time. And here in the bracket, we need to use microseconds. So in the Matlab, the symbol for the microsecond is backslash mu. It will give the value micro and s is second. Similarly, on the title, what have been defined on y-axis, you can see we have boldface, then italic slash normalize, then this is normalize is written in the italic. After that, we need the RM. RM will correspond to the normal font, normal type of fonts. Then VF will represent the boldface and signals. So when we execute this, the same will be reflected in the Y label like this. Okay. Then the title, font size is 14, bold face, in face, then IT will correspond to the italics, solid, RM. After that, we will have the normal font, then boldface and quadrature, IT again, italic, dotted, again RM is your normal font, backslash, boldface and signals. So when you execute that, the same will be written over it. Okay. Now, if you want to add certain text over here, we can use G text. So G text or text का क्या फॉर्मेट है? Point to वो लोकेशन है जहां पे टेक्स्ट अपीयर होगा. So these are the coordinates of x and y. 0.2 and 1.1. This is 0.2 and 1.1. We need to write pi by 2 face length. So when you execute it, you will be getting over here like this. And G text, if you want to add the arrow over here, simply click over here. So in the full screen, it will appear like this. If you want to change their properties, you can go edit. These are the axis property. We need to edit the figure properties. So किसी भी चीज को आप पिक कीजिए, उसकी प्रॉपर्टी यहाँ पे रिफ्लेक्ट हो जाएगी. और वो आप उसकी पोजीशन भी चेंज कर सकते हैं यहाँ से, इसका कलर भी चेंज कर सकते हैं. Okay, these are different colors that you can use for the combination of the different way, like this. Okay. Also, you can change the font size, font type, everything associated with the figures you can be changing over here. So there are two methods. Either you can define these changes by using certain handlers in the script file itself, or you can change them in the FIG file manually. एडवांटेज ये है स्क्रिप्ट फाइल में चेंज करने का कि आप एक बार उसे चेंज कर दोगे, कोड कर दोगे, तो मल्टीपल टाइम्स अगर आपको इमेजेस या फिगर्स क्रिएट करनी है तो एक बार ही आप चेंज करोगे कोड के अंदर, वो मल्टीपल इमेजेस क्रिएट हो जाएंगे. मैनुअल में आपको हर फिगर के अंदर जाके उसे चेंज करना होगा. सो आई थिंक दिस इज क्लियर टू यू. 2D प्लॉटिंग. Now we will move on to the advanced plotting functions. So multiple plots, also known as the subplots in a single window, if you want to create the different plots. Then the syntax is subplot is the function, bracket, define the rows, then comma, columns, and then the index. Index means how many images or figures you want to create. So let me perform the same for you. This is 2D plot, subplot. So close all is used to close all the files previously associated with us. So we will define close. I will clear the screen first. CLC, clear all the variables, clear all. Okay. So I have used the function subplot. When we use the subplot, 2 is the number of the rows and 3 is the number of the columns. So total number of the figures will be 6. 2 into 3 is equal to 6. So I will execute it and you will get this image. Okay, only one figure have been created over here because we have defined it as 6. So subplot 6 have been rendered as empty. Now I will define the first plot, 2 into 3 into 1. The first one, subplot 1. So first will appear, and in this I want to plot 1:10 numbers. So just execute this command and you will get this line. So first plot out of 6 we have created. Now we will move on to the second plot. The second plot is to plot the numbers from 1 to 20. So we will define second plot, and you can see it is varying from 2 to 20. It is a linear type of the plot. Okay. So we have defined, and in the third plot we want to add x and sin x. Sin x is the function that we want to create. We want to create the sine curve. So first we need to define the x. It is varying from 0 to 2 pi with the spacing defined over here. Then plot x into y. So y we have directly defined over here as sine x. So when you run this, you will get sine x. Okay. The next one is the fourth. Fourth plot we want to define as cosine curve. Okay. Fourth plot we need to define as cosine curve. So we will use the same methodology as we have defined in the third. So you can simply execute it all three together. We will get cosine curve, then tan curve, and cot curve. Also, if you want to change any of the plot in any of the cell we have defined in the page, for example, you want to replace the second plot, this one of the advanced plot command, that is peaks, you will simply run it. So the peaks will appear over here. Okay, so this is how we define the subplots. Also, we can perform the plots. These are the linear plots. We can define the plots as log plots. Log, सेमी log, ये plots भी हम create कर सकते हैं. जैसे कि 2, 3, 1 means first cell को मैं replace करना चाह रहा हूँ as a log plot between x and sin x. So you can simply say semi log y means y axis will be logarithmic scale. And in the first plot, subplot, we will be getting the plot between x and semi log sine of x. Okay, if you want to create the graph between log x and log sin x, then we need to define log x. अब ये सेमी नहीं है, सिर्फ दोनों में क्या है, x axis भी logarithmic है, y axis भी logarithmic. So this is how it will change. Further, if only on x-axis we want to define the logarithmic scale, then we define semi log of x only, like this. So this is how we can create the logarithmic scale also on the plots. ओके। सब प्लॉट 231, अभी इसमें इस कमांड में क्या करेंगे, प्लॉट y y मींस यू वांट टू क्रिएट टू प्लॉट ऑफ y. So first we have initialized the x, it is between 0 to 20 with an increment of 0.01. y1 is defined as a function of exponential of sin x. y2 is also defined, which is a function of exponential as well as that of sin x. So I will run this command and see what will happen in the first cell. So logarithmic decrement of the sine function is there and logarithmic decrement function is there of the different magnitudes. Okay. So अभी तक क्लियर है किसी सबको या किसी को डाउट है कुछ?
No sir, it's all clear sir.
Okay, sir. So then we will be moving to the next one, three-dimensional float. So one of the simplest example of three-dimensional float is 3D line plotting. So you can see the syntax is again like this: plot 3 will represent 3 dimension. X data we need to define, Y data, Z data, and then these are the different property styles associated with our plot. So X we have defined, let's say Z, in this case Z has been defined because Z is varying. Z has been defined as an array from 0 to 40 with an increment of 0.1. So 401 values have been defined for X. For Z, X have been calculated as X is equal to cos Z. So again you can run it, and Y is equal to sin Z. Again we will run it. Now the command is, we have defined X, Y and Z, which is the prerequisite of plot 3. And when you run it, you will be getting a helix or a spring type. Now you can do the manipulation with it. You can add the x's, x-axis, y-axis variable name, z-axis, or you can change the properties of it. So this is the 3D line plotting plot. Another example of plots associated with the 3D surface or line plotting is that you can use the peak function, which is the inbuilt function in the Matlab. You can create contours like this. You can obtain the sinc function or L-shaped membrane. So we will discuss a few of them. So how to create the contour plots? So again you need to define the values of the x and y. जो x और y है, इस पे आपको क्या डिफाइन करना पड़ेगा, ग्रिड डिफाइन करनी पड़ेगी जिसपे z की वैल्यू आएगी. So for example, you can see over here, we have defined that x is varying from -2 to 2 with an increment of 0.2. So ये x हमने डिफाइन कर दिया है. इसी तरह y डिफाइन कर दिया है, y axis. Now xy grid we will create based on these values, and these values will be stored in the capital X, capital Y. Mesh grid is the inbuilt function. ये grid बना देगा. Grid क्या बनती है, जैसे कि आपके horizontal and vertical lines होंगी, जहां पे वो intersect करेगी, वो एक आपका नोड बन जाएगा, और उस नोड पे हम z की वैल्यू डिफाइन करेंगे. Z is equal to, for example, x multiplied with exponential of minus of x square minus of y square. So हम यहाँ पे multiplication, division या से डॉट यूज कर रहे हैं. इस डॉट का मतलब यह है कि we are dealing with an array, not with a scalar quantity. We are dealing with an array. तो जब भी हम array के साथ किसी नंबर को या किसी नंबर को दूसरे नंबर के साथ जो arrays में हैं उनसे मल्टीप्लाई या डिवाइड करते हैं, तो उससे पहले हम डॉट यूज करते हैं. ओके, सो लाइक दिस वी हैव डिफाइंड द z फंक्शन. अगर मैं इसे रिमूव कर दूंगा डॉट को, सो इट विल शो एरर, मैट्रिक्स कंपैटिबिलिटी. So matrix multiplication cannot be performed because of incorrect dimensions. So I have created this dot and now run it. Now the z values have been calculated and we will use contour. So contour plot will be created. like this. Okay. Also we have shown that show the text on. So text on means हर एक जो इसका कलर है वो एक वैल्यू को रिप्रेजेंट करेगा. These will create isolines. These lines will have the same values of the z. Okay. So that values will be shown by using these strings, show text and on. Next one is another type of the command I will execute. But the difference is that I want to increase the width of the line by 3. So we can write it like this and execute. So you can see the difference between this one and the previous one is that we have increased the width of these lines. Okay, आप इसे rotate भी कर सकते हैं. Okay, this is the home view on which we have obtained it. You can also set the view by defining the azimuth and elevation angle. So let's say we will give 0 and 0 viewport. So this is how our image will align. Let's say it is 90. Okay, so like this it will become 0, 90 means I will explain the view command later on also. Okay, so how to set the plot perpendicular to x-axis, y-axis and z-axis, we can define it while using the view. Another 3D command is used as surf. So xyz value we are already having, so we can simply use the surf command also. Okay. The mesh is very dense, that's why it is appearing black. You can rotate it in 3-dimensional space. Also we can do the same by defining the view angle. You can also add the color bar to represent the variation with respect to z. So the z values have been varying from 0.4 minus 0.4 to 0.4. You can also set the values of this by editing the figure properties. Figure properties, and it can be created with interactive color shift. अगर आपको एक कलर वेरिएशन के अंदर डिफरेंट जोन्स चेंज करने हैं, यू कैन क्लिक दिस वन, इंटरेक्टिव कलर शिफ्ट, और इसे स्ट्रेच करोगे तो कलर की इंटेंसिटी आपके अकॉर्डिंग भी चेंज हो जाएगी. यहाँ से भी आप चेंज कर सकते हैं और इधर से भी शिफ्ट कर सकते हैं. तो देखिए वेरिएशन देखिए इसमें. Okay, next one is plot 3. One more command. This one. Plots will have been created by using this function. Zt is equal to yt and t. So all these xt, yt and zt, they have been dependent on parametric dependence on the value t. X is equal. X is equal का मतलब क्या है? दोनों एक्सिस को हम इक्वली सेट कर देते हैं. Water float you can also create. सरफेस में और इसमें क्या डिफरेंस है कि जो आपकी एजेस हैं वहां पे ऐसे लगेगा कि एक वाटरफॉल की तरह वर्टिकल लाइंस अलाइन हो जाएंगी. यहाँ पे ये देखिए, इससे पहले हमने सर्फ फ्लोट किया था, सेम वन, और यहाँ पे वाटरफॉल से क्या है, जो एजेस हैं वहां पे वर्टिकल लाइंस आ जाती हैं वाटरफॉल के तरीके से. ओके, सो इसी तरह आप बहुत सारे फंक्शंस हैं एक्सप्लोर कर सकते हैं. वन ऑफ द एक्सरसाइज इज टू प्लॉट द stress variation stress variation in a cantilever beam. So expression is given for the bending stress, and that will depend upon the beta, theta, and y. For the simplicity, we have used alpha, theta, and phi is equal to 1, and beta we have taken as -2. So for that, I have created the script. So the beta have been defined by b, which is equal to -0.2. X and y values have been defined. X have been defined from 0 to 6 and y -3 to 3. So you can change it accordingly. मैंने थोड़ा modification कर दिया था इसमें. So let's say it is changing from, okay, it is correct, 0 to 0.25 to 6. -3 से 3 vary कर रहा है हमारा y. Then we have created a grid of xy, mesh grid of xy in terms of x and y. Then z function. Z is nothing but your bending stress that have been defined as a function of x and y. And if I run it, this is the plot of the stress distribution in a cantilever beam. अब यहाँ से व्यू देखिए. अभी मैं क्या दिखा रहा हूँ? View is set to 90-90. This means it is normal to z axis. Z axis means हमने क्या किया है? Simply z axis से व्यू कर रहे हैं. We will be getting only x, y, and the value of the stress you can obtain by using the color bar. कलर बार से आपको स्ट्रेस की वैल्यू मिल जाएगी. अगर मैं इसे 90 पे सेट करता हूं व्यू पोर्ट को, so you will be getting between y and z 0 x and z view 45 and you will get 3-dimensional representation of it. Okay, तो ये एक्सरसाइज आप खुद भी सॉल्व करके देखना. मैं आपको ये पीपीटी और कुछ प्रॉब्लम्स भी शेयर कर दूंगा इसमें. Some more specific plots we can use is the stack plots. So for that we will define a data. हम एक मैट्रिक्स डिफाइन करते हैं by the name data. So this is how we have defined the data set. It is your 5x4 matrix, and again we will create our subplots using this. The first one is in the form of bar. So subplot 2x3 1, and it will be in the form of bar. So you can see the representation of it. इसकी representation देख सकते हैं. The first one, what is the total value? पहले 10 है देखिए फर्स्ट में. So there are 5 bars over here. 5 बार है हमारे पास, 5 रो है. तो इन सब का सम क्या होगा? It is 20. So 20 is represented over here, as well as the individual values have been signified over here with different colors: 10, 2, 3 and 5. सेकंड के लिए, थर्ड के लिए, फोर्थ के लिए एंड फिफ्थ के लिए. फिफ्थ के लिए 4. Then the next value is 7, which is the maximum of the fifth element. Then we have the 5 and 3. So this is how you can create a stacked plot from a given data. Area plot भी create कर सकते हैं. For example over here. So again, 1 का total area कितना है? 20. Of second, 5 plus 8, 13, 23, 26. So you are getting 26 stacked area and so on. So these graphs are used for data representation purposes. Then bar 3h, like this we have defined. So first one is your 10, then 2, 3 and 5, then second row, third row, fourth row. In terms of percentage, the percentage of all these. So we will do what we will do. We will sum up all the data, y3, sum the data, okay, and then we will create that the first column will correspond to 31%, first row, second row 26%, the sum of all these. Also, we can create the historical hysteresis diagrams also. So over here we have not used the data defined over here, but we have used the random data हमने लिया है, okay, random number लिए हैं, ran, it is a function to create the random number. So this random number have been created in 3 columns, 1000 numbers. इस तरह ये क्रिएट किए हैं. इन्हें हमने मिनिमम और मैक्सिमम की वैल्यू के बीच में स्टैक कर लिया है 10 बीन्स के अंदर, and then these beans have been plotted over here. So this is how these histograms have been created. Another function is subplot rows. You can see. So again, random number have been created, 1000, single column, multiplied with 5 by 3. And this time we have used 18 bits to segregate them from the maximum to the minimum value. इस तरह का segregation किया. Type of the plots will be obtained. Subplot for impulse function. Impulse function plot करने के लिए we will use, first we need to define z impulse. We will use the impulse. T is defined as the variable, z is the dependent variable. Impulse function inbuilt function impulse have been used, and then stairs. This plot is known as stairs की तरह ये create करेगा. Now the stairs have been created between t1 to 5, means हमने t की कौन सी वैल्यू पिकअप की है यहाँ से 1 to 5, 1 2 3 4 5, and then to end. From 1 to end we have taken a gap of 5, means first value 1 आएगी, then 6, 11 and so on up to end. Similarly हमने z की जो वैल्यू उठाई है वो भी 5 5 के इंटरवल्स पे उठाई है और ये स्टेयर्स के फॉर्म में एक ग्राफ ड्रॉ कर दिया है. Stem, another function. Now the stems have been created, individual values के ऊपर हमने एक सर्कल करके उसे stem बना दिया है. So how to define it? We have defined the theta, x value we have defined, y value we have defined, then z is taken as absolute of, we have created fast Fourier transform. 10 by 1 का हमने एक डाटा कलेक्ट किया है and 75 के फास्ट फोरियर ट्रांसफॉर्म से हमने एब्सोल्यूट वैल्यू इमेजिनरी को डिसरिगार्ड किया है. We have taken only the absolute or the real values of the z, and then we have plotted them as stem plot, 3-dimensional plot x, y, z. One more type of the plot is the curve plot, which is used to represent the gradient. Gradient not in the form of the your color variation, but in terms of arrows. अगर कोई प्रॉपर्टी है आपको एक डायरेक्शनल प्रॉपर्टी दिखानी है कंटूर प्लॉट्स में, then we will use the curve. So first we have used the peak inbuilt function, and this function between will create a grid from x to y between -2 to 2, -2 to 2 in the both the x-axis and y-axis. So it will assign x, y, and z value to it. Then u will be defined based on the values of the z. The gradient again an inbuilt function. So ये z के basis पे हमें uv की value मिल जाएगी. So you will be getting the gradient at a spacing of 0.25. Then we will create the contour plot. इससे contour plot से ये हमारा create हो गया है. Okay. So we are getting 10 contours of x, y, z. जो ये contours हैं एक कलर का एक represent कर रहा है, total there will be 10, and then we have defined curve x, y, u and v. So x, y we have defined, u and v are the gradient. So the direction of the gradient are shown by these arrows. Now subplot, polar type of the plots. The polar plot will be in terms of theta and r. This is the polar plot. First, we need to define theta. This is from 0 to pi. Then R, radius, line space. Line space is another command used to create array. So it will create 126 instances number between 0 and 1. Okay. Then we use this command polar, theta and r. So हर थीटा की वैल्यू के लिए ये रेडियस हमारा क्या हो जाएगा, प्लॉट हो जाएगा. So this is how this command will work. Another one is compass. तो पोलर कमांड में हमने दूसरा रिप्रेजेंटेशन का मेथड है ये. सो इट विल बी क्रिएटेड बिटवीन, कॉन्टिन्यूअस लाइन क्रिएट नहीं होगी, लेकिन जो जो पॉइंट्स हमने मार्क किए हैं ओरिजिन से वहां पे एक एरो चला जाएगा. जैसे इसमें एक ऐसे राउंड हो रहा था, कॉन्टिन्यूअस लाइन मिल रही थी. सो अब हम क्या करेंगे, हर पॉइंट्स को ओरिजिन से कनेक्ट कर देंगे विद द हेल्प ऑफ एन एरे. सो द मूवमेंट विल बी अगेन द सेम लाइक दिस. सो इन दिस वी यूज pole to cart. This is an inbuilt function which is used to convert polar coordinate system to Cartesian coordinate system. So theta have been taken with a spacing of 5, means हर 5 को हम नंबर को स्किप करने के बाद आगे बढ़ रहे हैं थीटा की वैल्यू पे. Okay. So the last plot, special type of the plot is feather plot. So you can see feather plot between x 1 to 19 and y 1 to 19. Means जो x की वैल्यू है वो 1 to 19 वेरी कर रही है नंबर, y की वैल्यू भी 1 to 19 वेरी कर रही है. And then we have plotted all these points. Then an arrow will be going from x value to the y value. जहाँ पे भी x एक्सिस पे वो x वैल्यू आती है वहां से एक एरो डायरेक्टली जाएगा y की वैल्यू पे, and you will be getting this kind of the features. This is known as the feather flow. Okay. So this is all we have discussed. Now, how to extract the data from any image by using the Matlab. So data extract कैसे करते हैं? Suppose we create a मैजिक मैट्रिक्स. एक मैट्रिक्स क्रिएट किया मैजिक ऑफ 4x4. So you can see that what is so special about this magic matrix is that the sum of each rows and each columns will be equal in this. अगर आप किसी भी सारी रो को का सम अप करके देखोगे सबका सम एक ही मिलेगा, कॉलम का भी सम सेम ही मिलेगा चारों कॉलम्स में. So we have created this matrix. Now we will create the image of A. एक ही image create कर लेते हैं. So like this an image will be created. Now we will map this on HSV plot. HSV plot एक color plot होता है which is used by the Matlab to represent the color variation, to represent the continuous contours using gradients of the color. So of 16, we will create a map of HSV 16 colors by using this one command. Okay. Then we will map this HSV onto the image by using map color map. So you can see this image will be created. अब हर एक सेल के अंदर एक नंबर था. So for example, फर्स्ट सेल हमारा 16 है. 16 इज द मैक्सिमम वैल्यू. सो इसका कलर भी क्या रिप्रेजेंट कर रहा है, मैक्सिमम वैल्यू रिप्रेजेंट कर रहा है. ईच सेल विल बी हैविंग द डिफरेंट कलर. सो इफ वी ऐड द कलर बार ओवर हियर, सो 16 टॉप पे है, मिनिमम क्या है 2 है. और मिनिमम वैल्यू 2 कहां पे थी हमारी, इट इज मिनिमम वैल्यू इज द 1 एट द बॉटम मोस्ट. सो बॉटम मोस्ट में 1 है. सो द वेरिएशन इज फ्रॉम 1 to 16 and the individual color will reflect these values. So where use it? हम कहाँ पे यूज कर सकते हैं, हम टेम्परेचर रीडिंग्स के लिए, वेदर फोरकास्टिंग के लिए, such type of the image we can take. We can load these images in the Matlab and from there we can develop the humidity variation, temperature variation data that can be created by using these type of the images. Okay. Now saving the images, that I have already told to you that we can save the images in .fig, which is the standard format for the Matlab, but we can also save using the TIFF file, also the JPG file. Okay, and we can also print all these figures individually by using the commands. So this is all about the plotting. The next topic will how to change the properties by using certain handlers. If anyone is having doubt, then we can discuss. किसी को डाउट है?
We will take down at the end of the session, sir.
Okay. Okay, sir. Okay, now to start with this, how to change the properties, we need to define the different properties associated with the graphics. So we can develop a hierarchy between the different objects of Matlab. So you can see this diagram, which will represent the hierarchy between the different objects. So the root string is basically the screen of the window, and there established a parent and children relation between the figures created by the Matlab. Now the figure will act as a parent for user interface control of the figure file, axis, and user interface menu. Now the axis will act as a parent for image line. Image will correspond to the plot area, line, patch, surface, text, or the source of the light. So this has been represented by this one over here, you can see. So we have root object, then figure object, user interface menu, user interface control, surface object, line object, axis. So we can change the properties of these by using some standard inbuilt functions. So how to obtain an object handle का मतलब है कि उसकी property अगर हमें change करनी है तो उसकी property हमें कैसे मिलेगी. So we can define the handler, this handle as h underscore line is equal to plot xy data. So simply we can feed the value of that function or that command into a separate variable. We can define the separate variable. Utility function, normally we define to set the property or to get the, in this case we will get the property, get the properties of a figure, get the properties of the axis, and get the properties of a particular object. These are some inbuilt function in the Matlab. Also, you can find the properties of a particular object by using this command, find object. This is a function. H parent is the property of the object which you want to obtain. Property such as अगर आपको H line के अंदर ही आपने एक प्लॉट को H line के अंदर स्टोर कर दिया है. So you want to check, आपको ये चेक करना है कि इसमें फॉन्ट टाइप क्या है या कौन से ऐसी प्रॉपर्टी है जिसका फॉन्ट टाइप हमारा टाइम्स न्यू रोमन है. सो यू विल सिंपली राइट h ऑब्जेक्ट इज इक्वल टू फाइंड ऑब्जेक्ट obj parent, प्रॉपर्टी क्या आएगी, फॉन्ट नेम, एंड द वैल्यू विल बी टाइम्स न्यू रोमन. सो इट विल लिस्ट डाउन द different objects which have this property in that particular image. So we will solve it by using certain examples. For example, let us open the 2D plot image that we have already stored or saved. So ये image हमारी open up हो जाएगी. So we have stored that in H. We want to search the type. हमें axis check करने हैं, axis में type line किसकी है. So we will execute this command. You can see that a variable have been created as h1 over here. जब आप इसे क्लिक करोगे Okay, it is not opening. So you can see that H line will have it has find two lines basically. In this we have stored two lines. So what I want to know the values of or the data associated with these two lines. So इस फिगर के अंदर होना भी यही चाहिए था. दो लाइन है हमारे पास साइन वेव की एंड कोसाइन वेव की. So we want to extract the data of these two lines. अगर हमें इनका डाटा एक्सट्रैक्ट करना है. So we have defined x is equal to get h1 x data. This is the standard format. So x के अंदर हमने क्या स्टोर करा दिया इसका x data. Now we will evaluate this command and this is how you will get the values of the x. So two cells have been defined. You can see x where it is. This is x. इसमें दो सेल हैं. So when we click the first cell, it will open up. These are all x values. x11, x21, second x की जो ये values थी. Okay. So this is how you can extract the data. Y get के अंदर हमने y data store किया है. Again, it will be stored in the form of cell of 2 into 1 array, and these are the values of the first function and second function. So ये जो first function है ये हमारा cosine function है. The second one is for the values of the sine. So you can see that values from over here also y. This symbol will represent the cell. In the cell we are storing two variables. Now these values are for the cosine curve and these values are for the sine curve. So इस तरह आप ये डाटा यहाँ से ले सकते हैं. Next one we want to from the axis GCA axis से हमें क्या फाइंड करना है font name. वो सारे font name जिनका Helvetica category है that we want to find in the H2. So we will evaluate that and you will get that this is the axis which will be stored as Helvetica and this is the text in which the text has been used as Helvetica. इसका font name ही आपको लेना है, so you will use the get. Okay, font name, nice property. Font size. Okay, I will see. There is some issues. Error is over there. Okay, we will come to that later. For example, third, we want to find the color. Now, this is the representation of the color in the Matlab of any line or any text. 100 means RGB. R will represent 1 means it is a red color line, and G represent the contribution of green, and B, the third one is blue. Its representation is 0. So it is a purely a red color font. So we want to find the object whose color is red. So you can see that these are the properties of the line associated with the line style is your dashed. So you can see from here. This one is the dashed. Marker is O and the size of the marker is 6, and also you have get the data, X data and Y data associated with that line. अगर आपको H जो इमेज हमने H में की थी यहाँ पे H हैंडल में स्टोर की थी, इसकी सारी प्रॉपर्टीज आपको फाइंड करनी है, यू कैन यूज गेट H. तो यहाँ पे आपको गेट H से all the properties that are associated with the image will be displayed over here. ठीक है, फॉन्ट स्टाइल जो भी सब कुछ है यहाँ से आपको मिल जाएगा. सेट H मींस यू वांट टू सेट द प्रॉपर्टी. कौन कौन सी प्रॉपर्टीज सेट कर सकते हैं ये आपको सेट H से मिल जाएगा. यू वांट टू चेंज द प्रॉपर्टीज. फॉर एग्जांपल GCA, you want to store the properties of the axis in AX variable.
सर फॉन्ट में F कैपिटल आई गेस होगा. फॉन्ट नेम में देखिए तो चेक करके उसे फॉन्ट का जो फॉन्ट नेम में एरर आ रहा है वो F कैपिटल करके ठीक होगा.
नहीं सर, कुछ और ही है एरर इसमें, देखते हैं बाद में से. ओके ओके, सो AX is equal to GCA. GCA means property of the axis have been stored in variable ax. Now I want to set the axis font name to the times. एक्सिस को के जो fonts हैं उन्हें मैं टाइम्स में सेट करना चाह रहा हूँ. So we will first put the image over here and we will run this command. So when you run this command, you can see that the axes have been converted to times. And if you want to set them to the weight as normal, so they will come to normal axis. If you want to change their color to blue, so 001 represent the blue color. So इसकी background क्या होगी अभी? Blue होगी. So like that you can change. You can also define the font size that AX font size set to 16. Axis का font size 16 set करना है. 16 हो जाएगा. Tick marks हैं जैसे ये, which have been defined inside the graph. Tick marks inside है, you can move them outside. Axis की limits भी इस तरह set कर सकते हैं. So simply हमने क्या किया? जिसकी axis की सारी properties AX में store कर दी है. Then AX dot the property name, you can define the values of those properties. आप उन्हें change कर सकते हैं. Okay, so this is all about get set. Now set 0. Set 0 का means already predefined values हैं, ये उसी में ही change हो जाएंगी. जैसे again we will use the same image. Let us close it. So we will create an image using this command. Surface command create करते हैं. Surf. Okay. So this we have created by default. The color of these edges is black. Now, if you want to change it, we can simply rewrite it as to green. Green is the default. Okay, set edge color to black. Edge color. Okay. So now the edges have been turned to blue. So by default it is green. We have set already green. Again, if you want to set it to default, you can use the edge color as default, the one which has been already defined in the Matlab file. Okay, GC means of the figure. Figure की properties है. अगर आप उसे factory पे set करना चाह रहे हैं, get the properties of the figure. And if you want to set it to the factory default, if you want to remove that, you can remove the set GCA. So like this, there are many features that are available to us in the Matlab, which can be used more efficiently when we are coding a particular script file. You can use them. Okay. So now our next topic is to solver. So we will be discussing two problems based on the ordinary differential equation and one problem on the partial differential equation. So let us start with this one. We are having a simple ordinary differential equation that have a single solution component. So we have y prime is equal to 2t. Y prime means its derivative with respect to time. We have specified a time interval of 0 to 5 and the initial condition is 0. At time t is equal to 0, the value of y is equal to 0, and this derivative time interval is varying from 0 to 5. So we can solve it by using the inbuilt solver ordinary differential equation 45, OD 45, it has been defined. So how to define it? How to solve this problem? So first we need to define the time span. So the time span is our 0 to 5. We can define it like this. We can execute it. Okay, T span is 0 to 5. Then initial condition at time is equal to 0, y is also equal to 0. Okay, then this inbuilt function will be used. The syntax is that OD45, 45 will represent that it can solve the partial differential equation up to the fourth order, and fifth is the truncation error associated with it. So at ty, okay, so we have defined partial differential equation in terms of ty. The value of the first derivative is 2t that we have defined. T span we have already defined, and the initial value. So, okay, so this will define the dependent independent variable. This is the value of the derivative and the time span, and this is the value of the initial boundary condition. So once you put up this command, it will the solve you the expression for y, which you perform by performing the integration. So when I will run this program, it will solve it, and you will get y is equal to t. Y is a function of t. Okay, with O marker I have plotted it. So there are different types of OD solver available: OD113, OD45, OD34. That will be depend upon your कि आप ऑर्डर पे जाना चाहते हैं सोल्व करने के लिए, पार्शियल डिफरेंशियल इक्वेशन किस ऑर्डर की है, आपका सिस्टम है या नहीं है, कितनी एक्यूरेसी आपको चाहिए. So all these parameters you need to select your OD. Another one is OD solver that you can solve it by using the van der Waals equation. It is the second order equation. Like you can see, y1, the variable have been defined. It is the double derivative minus mu2 minus y1 square into y1 derivative plus y is equal to 0. So u is greater than 0. So जो ऑर्डिनरी डिफरेंशियल इक्वेशन सॉल्वर होता है मैटलैब का, उसका एक अपना स्टैंडर्ड फॉर्मेट होता है जिसमें आपको इक्वेशन सेट करनी होती है. सो इन दिस केस, so it will be defined in terms of the first order or the first order derivative. So what we can do, we can define the first derivative of y1 as y2, and when we substitute this value as y1 as y2, we can define this equation, or it will reduce to this form. इस फॉर्म में reduce हो जाएगा. ठीक है. So we have defined a variable. It is equal to the first derivative of y1. So y double prime or y double y2 derivative is equal to u1 minus y1 square into y2 minus y1. So VDP, van der Waals function we will be used, and it will have t and y as the independent and the dependent variable. Then we will define dy by dt as a variable or as an array in which y2, okay, this y2 is nothing but this one y2, and this is the expression for the second derivative y1 double prime or y2 prime. So this expression will represent that value. Now we will use OD45 with the input at VDP1. Now this will represent from 0 to 20. This will represent the time, and 2 and 0, these are the boundary conditions associated with the partial differential equation. When you run this code, you will get again you will get the graph like this. So what we have got, y1 and y2, the solution we have got with these two legends, with mu is equal to is have been for van der Waals. Okay, the next one is to MATLAB PD e-solver. So there are different types of solvers available to us for the partial differential equation. So I have been elaborated over here where they will be used. So in this session, I will be only taking with the PDEX1. So the PDEX1 solver will be used. It is a simple partial differential equation that illustrates the formulation, computation, and plotting of the solution. So there are two types of the equation with which we can solve the PDE solver, and these are this partial differential equation is u. U is your dependent variable. It is dependent on the time, and x. It is a 1D problem. All these PDE x1 to x5 they are used to solve one-dimensional or 1D equations. For two-dimensional and three-dimensional equation, you can either use symmetry in the PDE solver, or you can go with the one module is there, differential modular module of the MATLAB. You can proceed with that one for the two-dimensional partial differential equations. So this type of the equation in which both the t and x are there, they are known as time derivative equations that are parabolic in the nature. And when there is no derivative exists, then that type of the equation are known as the Laplace equation. They are of elliptical form. So we will, in this particular session, we will be dealing with the parabolic equation in which the dependent variable will be depending on the time as well as the space in one direction. So this equation we have taken, okay. So this is the zone. This will represent the heat dissipation in one direction. The domain is from 0 to L, and time is also given for a certain duration of the time. So our goal is to solve for the temperature distribution along the x direction. The initial temperature has been assumed ux0. The second one is for the time. At time is equal to 0, the temperature is T0. And this one is defined, these boundary conditions have been defined on the basis of the space. Means when x is equal to 0, and when x is equal to L, the maximum dimension, it is equal to 12. So first and foremost is that you need to convert this equation into the standard form which the MATLAB understands. OD solver, जो PD solver है आपका, जिस लैंग्वेज को या जिस इक्वेशन को वो समझता है, आपको इसे उस फॉर्म में कन्वर्ट करना पड़ेगा, एक जनरलाइज फॉर्म में. एंड दिस इज द जनरलाइज फॉर्म ऑफ द इक्वेशन दैट इज एक्सेप्टेबल टू द PDEX1. So it has been defined as C, which is a function of x, t, u and curl u by curl x into curl u by curl t is equal to x minus m. Then again the derivative, in that we have xm, then the function f plus function s, which is again dependent upon x, t, u and curl u by curl x. This is the standard form of the PDEX1 solver. So when you want to fit this equation over to this expression, you can simply say that C is equal to 1. Only we are having curl u by curl t. M is 0. Okay. And this function is nothing but curl u by curl x. And this function S is also equal to 0. So we will be getting these coefficient we will obtain by comparing these two equations. M is equal to 0, C is equal to 1, F is equal to curl u by curl x, and S is equal to 0. Now we need to define a function CFS, heat P, and the input are x, t represent the time, x represent the one-dimensional space, u temperature, and the temperature gradient. So this function we have defined. Then we will define the values of the coefficient, and then we simply save this as a script file. So this script file has been saved like this as heat PD. By this name it has been saved. Where it's, this is heat PD. It has been saved like this. The next objective is to define the boundary conditions. Boundary conditions को define करेंगे next में. So the boundary conditions are that another function has been defined, initial condition. Initial condition is, I see boundary condition. Okay. So U0 heat IC again the function of x. So U naught is equal to initialize. We have initialized this value. U is equal to 0.5. Next boundary condition is based on uh, this is the standard format of accepting the boundary condition by the Matlab in case of PDEX1 solver. So this is how it has been defined. P again a function of x, t and u plus g, q, x and t function, and then f as a function of x, t, u and curl u by curl x. Now when you compare or when you substitute the value depending upon our original problem, you will see that in the first we have defined that u is equal to 0 at x is equal to 0, so that we need to ensure. So in that case q will become 0. To make u at 0 at a given time at x is equal to 0, it will be equal to 0. And u at l equal to t is equal to 1. So for that we need to get q is equal to 0. And this minus 1 we will obtain here, and it will be equal to 0. Now the function will be defined as PL, QL, PR, QR. PL represent the left, means the starting side, x is equal to 0. These are the values of at the extreme left, PL, QL, and these are the values at the extreme right, PR and QR. Heat boundary condition, the input is XL, UL, XR, UR, and T. And these values, as defined over here, they will be substituted as it is like this. So what we have done, we have defined the equation, we have defined the initial condition, we have defined the boundary condition. Now we will go to the solver. So for the solver, this is the heat PD solver. So L is equal to 1, the length along the x direction. This is it. So L is equal to 1. So you can see uh, from x is varying from 0 to L. So the value of L we have taken as 1. So we can substitute this value L is equal to 1. Yes. अभी lecture में हूँ. Oh, sorry. Okay. So x we need to define the space. We need to build the grid for which we want to generate the temperature profile. So for x we have defined L link space 0 to 20, means between 0 to 1, L is equal to 1, we will be creating 20 points to calculate the temperature. And the another one is to calculate the time or to define the time. So between 0 to 5 seconds or 0 to 2 seconds, we will define a grid for having five time space, 5 values of the time. And we have taken as 0. So this is the inbuilt function PD EPE. It will take input as M. It will take the input as PDEX1, initial condition, boundary condition, okay, X and T. So let me change it to heat. So this function will call all the functions of initial condition, boundary condition, the correct name I need to apply. And now it will solve for the temperature distribution. So the temperature it has calculated. Now I will develop the, using the 3D command surf, I will develop the surface temperature distribution for the 20 mesh grid points. So when you can evaluate it. Okay, it's showing you U is undefined. Okay.
Sir, soul, I think soul will be there instead of you.
Just a minute. Sir. Unrecognized variable. X, T, and U.
Sir, soul will be there, I guess, instead of you. Soul. Uh,
यहाँ पे तो सर सॉल्व हो चुका है ये।
नहीं,
ये तो प्रॉब्लम यहाँ पे आ रही
in place
है।
of you, it should be soul otherwise.
ये सोल से हो जाएगा, ये सोल हो चुका है, यहाँ तक हो चुका है सोल से भी।
नहीं,
सर्च में सर्च
फिर
कमांड में
you, हाँ.
एरर यहाँ पे आ रहा है। Unrecognized function of variable U.
You is in soul itself, ना? SOL, soul. Instead of you, अगर हम soul लिखते हैं तो soul solution नहीं है.
अच्छा अच्छा,
हाँ, you की जगह soul आएगा यहाँ पे.
ओके ओके, ठीक।
Yes.
So this is the temperature distribution. Okay, so this is the analytical solution for the same problem. And if you want to generate the true solution, means the analytical solution, exact solution, it will be the same. ये इसका analytical solution, true solution. And if you want to compare the solution at time is equal to 2, means at the final, at the end of the simulations, if you want to calculate what is the temperature distribution by using the both the case.
Sir, वो line, sir 18 line में भी you की जगह soul.
So you can use so this is the variation. Variation ऐसा क्यों आ रहा है? T is equal to 2 पे सोल्व किया था हमने. ठीक है, ये दोनों मैच करने चाहिए, मैच करते भी हैं. कुछ वैल्यूज मैंने चेंज कर दिया लगता है बीच में.
नहीं, हाँ सर, नंबर ऑफ पॉइंट्स शायद कम होंगे पार्शियल पीडी में जो हम लिए, और ज्यादा लेंगे तो वो सॉल्यूशन एग्जैक्ट हो जाएगा.
x और 0.2 t की वैल्यू क्या है? ठीक है सर, तो that is all, and these are the assignments. So the assignment is basically they are based on the plot commands. I will add 2 or more problems based on the ordinary and the partial differential equation also, so that this will be the entire thing that I have covered in this session. So 2 more problem I will add and then I will share it with you.
Thank you so much, sir. Such a knowledgeable session.